Okay, so good evening all the students. Welcome back again to the next episode of Shikuyaa Campus Placement T20. As you know, we have started this particular talk series from 26th of January and that will continue till 14th of February. And in this entire talk series, there will be 20 eminent professionals from industry, academics, and training and placement ecosystem. Those who will be coming live and they will be sharing their experiences, they will be sharing their thoughts on one particular topic, which will help all the students into their career journey, into their campus placement, and many other things. So in our today's talk, we have a very honorable guest speaker, Dr. Prasanna Deshmukh sir, and I'll just briefly introduce him. And he is going to address on a very interesting topic for all the students out there today. So let us have a great introduction by one of the very eminent professionals from the industry today. So Dr. Prasanna Deshmukh has completed his doctorate, PhD and MTech degree in astronomical instrumentation from Indian Institute of Astrophysics and University of Calcutta in respectively January 2021 and August 2013. So he has completed his PhD thesis on the topic modeling, simulation, and implementation of primary mirror control system for the prototype segmented mirror telescope. He has worked on development of precision controller for TMT actuator and ITCC laboratory of IIA. For his master's thesis, he has also, I'm very much proud and I'm very much delighted to say this, he has completed his bachelor's degree from PVPIT Budgaon. So he is from the same vicinity, same region where we all people are belonging. And then he was also a student of integrated MTech PhD in astronomical instrumentation at IIA Bangalore between 2011 to 2017. And between December 2017 to May 2020, he was working as a project engineer at India 30-meter Telescope Coordination Center at IIA Bangalore. From June 2020, he is working as an engineer at IIA Bangalore with the prime responsibility at Work Package Manager for India TMT M1CS actuators and 8 sensors. He has published several research papers in reputed journals. Presently, he is working on 2 major astronomy projects, 30-meter telescope, that is TMT, and Indian Spectroscopic and Imaging Space Telescope, INSIST. So his interest lies in telescope control systems, active optics, control system modeling, and simulations, astronomical instrumentation, astronomy outreach. So he has a very huge exposure, experience, and expertise into all the things which are related to the astronomy, all the things which are related to space science, control system modeling, and all these kind of things. So students, we all are very much fortunate today to get addressed by him, one of the very much eminent professional. And I must express my sincere gratitude and I must thank him for being available here for all of our fellow students and giving us this chance to have this platform for all of our students. So thank you so much, sir. And over to you. You can start. You're on mute, sir. Can you just please?
Yeah. So thanks a lot, Chetan, for such a nice introduction. Maybe this is the first time I'm getting introduced so nicely. So thanks again for that. I would also like to thank Swapnil and Prasanna, who kind of managed to kind of put this together for having this particular talk and interaction with you. So in this today's talk or presentation, I would like to kind of briefly take you on the journey, short journey rather, of how I kind of pursued career in astronomy, right from a small dream after seeing stars to actually looking at the stars through world's biggest telescopes. As well as I would also like to show you the path of doing career in astronomy by giving some tips as well as some information or some facts which are not commonly known, though it is very evident and people are doing career in astronomy at a large scale from all over India. But where I come from or where you are located, from there, looking at this particular field, it's a bit alien field. And of course, aliens belong to our field. But yeah, so today I'll just give you some brief about how we can pursue career. And one of the most important thing I would like to mention is like, if you have any queries, questions, feel free to ask. It may be about this particular topic or any other recent happenings you might be following on internet about the astronomy. So anything related to astronomy, I'm here to clarify your doubts, and let's get started. So yeah, I assume that my screen is visible. If not, then let me know. So I'm Prasanna Deshmukh. I belong to the same place where all of you are joining. I'm from Sangli. I spent my 25 years there in Sangli without going to any major city outside Maharashtra. Whereas coming to Bangalore was my maybe second visit outside the vicinity of Sangli or so. So I spent entire kind of initial phase of my education, right from school, college to undergrad at Sangli, and presently I'm working as an engineer at Indian Institute of Astrophysics, Bangalore. So as I said, I had done my BE in electronics and telecommunication, and after that I joined the Indian Institute of Astrophysics for doing MTech in astronomical instrumentation, followed by PhD in astronomical instrumentation. This is a MTech PhD integrated program. But when I assume that astronomy is something special and something rarely known field for doing career. Of course, we see ISRO scientists, NASA scientists, and scientists in general. But how to go there and how to be one of them is kind of less known at our place. So I'll tell you my story in very brief. Of course, if you are interested in further details and further bits and pieces of that, it is already covered in one of the video which was made by IA. It says about my science story, and it's on one of the science channel also called Science Nonsense, which I operate on YouTube. So maybe if you get time and if you're interested, you can look at it, where you can get to know detailed story about my journey. Whereas starting for astronomy, the reason why I started dreaming about astronomy or thinking about astronomy was it was in my school days, in around 8th standard or so, when my colleagues from other classes, one of them wrote a letter to Dr. Jayan Narlikar from Ayuka, and within few days he got a reply to that letter, and it was such a big thing for me to even know that Jayan Narlikar has replied to one of our fellow students. And then I was so kind of thrilled by the fact. And then I also wrote the letters, and I knew Jayan Narlikar from televisions. You might be aware of one web series used to, or not web series, sorry, one television series used to be there called as Surabhi, in which Jayan Narlikar used to come as a science expert. And I knew he is a very great scientist. And then when I got to know he has written letter and got reply, I also wrote a letter. In fact, I got a reply from them, but my letter was something a bit serious, that I wanted to tell him that I want to be like you, and how can I be scientist, or how can pursue career in astronomy. And he, when the response letter which I got, there was mentioned that I should do BSc and then followed by MSc and then do PhD. But in the end, he also mentioned that there is a path to do astronomy through engineering, and that fascinated me, because in general I was interested in engineering too. So, and engineering is something which is easy to do at our place, but being a scientist is not something conventional, to be honest. So I thought that, okay, looks like doing engineering also you can pursue career, so let's do that way and see what happens. So that's why after my 12th I went for bachelor's in engineering, and I did it at PV at Gudgaon, and I was one of the classmate of one of the participants here, or coordinator here, Sandeep. And yeah, so while I was doing B, I also realized that I'm interested deeply into astronomy and I wanted to do something about it. Unfortunately, at Walchand College of Engineering, there was one astronomy club called Gaganvedi. So I got associated with them in my 10th standard or so. And from 10th standard till my end of engineering, I was associated with them, got to discuss a lot of things. And through them only my interest was kept alive. Of course, I was not doing any serious astronomy. But towards my BE projects, I realized that I need to do something which might be relatable to astronomy. And hence, with my project mates, I kind of got involved into building one radio telescope. It was a low frequency radio receiver. And then followed by in my final year, we built a weather station. It was somewhat related to astronomy, but the radio telescope was definitely related to astronomy. So I wanted to express my interest in astronomy through uh, doing this kind of projects. Of course, I was learning a lot of things about astronomy. I was good at astronomy and bad at engineering, to be honest, at that time. That's why I used to get average marks, but I was very much fascinated by the astronomy. So later on, after my BE, I did kind of study for GATE examination, and through GATE, because I knew that I had to do MTech. Of course, I was giving exams related to direct PhD in astronomy as well, but I couldn't succeed to qualify them. But I managed to qualify through GATE examination, and then I was lucky to be selected at Indian Institute of Astrophysics. Why I'm saying lucky? Because every year only 2 or 3 students get opportunity to get admission in this particular course, and I was one of the 3 people who got admission that year. And most importantly, of course, I was having very good gate marks, but most importantly, I got selected because in the interview, which was conducted by almost 10 panel members, as well as it went for around 1.5 hour, wherein 80 to 90% of the interview was on my past activities, which I did at uh, my engineering college, and whatever the projects I did, and how I'm interested in astronomy. So that particular aspect helped me to kind of convince them that, look, I'm interested in astronomy. I may not be good at subjects in my bachelor's, but I have scored good marks in GATE. So consider me for this particular post. And then I was fortunate to get admission, and then the rest of the things are kind of those are the things which went automatically once I got into MTech. Then I was able to go
Sir,
into yeah.
sir, just a minute. Can you just please stop your screen sharing, because I have to
Yes,
just
yes,
disable this annotation.
correct, correct.
I'll share my screen, disable that, and you can start.
Yes, yes.
Yes, you can do it.
All right. Yeah, so as I said, like rest of the thing is just a history kind of thing. Last 10 years, I'm associated with the Indian Institute of Astrophysics, did a lot of astronomy projects, which are like serious research projects. And I did complete my PhD in astronomical instrumentation. My topic was on segmented mirror telescopes. It's basically about building large astronomical telescopes by using small kind of modular telescopes. And that particular understanding is helping me to contribute for one of the largest astronomy project which is coming up, which is under progress of fabrication and installation at Hawaii. So that is 30-meter telescope. And of course, being involved into electronics related aspects for last 10 years, I'm able to also utilize some of my expertise in one more space telescope project, which is called as INSIST. So yeah, with that brief, I would like to take you to the other part of my presentation. But as I said, if you're interested to know in detail, you can watch that video. Yeah, so presently I'm working on INSIST telescope. So INSIST is basically Indian Spectroscopic and Imaging Space Telescope. So this is going to be a UV space telescope, and it will be around 1.5, 1 meter. Just a minute, I'll share it again. So INSIST is going to be a 1 meter space telescope, but it will be in UV domain. So it will observe the ultraviolet rays. And the reason why we are sending it to the space is because this will be observing UV rays which cannot come to the ground. And hence, if we have to observe UV radiations, we have to go in space. And this is going to be the world's kind of one of the biggest telescope when it will be launched. We are expecting to launch it in 4 to 5 years time. ISRO is partner in this particular telescope for launch vehicle, and the hardware is getting fabricated at Indian Institute of Astrophysics. And Canada is also part in this particular telescope to share the technology which complementary technology which we are lagging now. So
just a minute, sir.
Yes,
just
yes.
A minute.
Yeah, now I'm able to share. So yeah, so we are having some complementary technology which we are sharing. Of course, ISRO is well equipped with the very good launch vehicle, and Canada is having a very good electronic expertise. So we are combining detectors and other aspects. So we are combining our expertise of both the countries and trying to build this one space telescope called as INSIST. Now, as you know that recently there was a telescope which was launched called as JWST. It is called as James Webb Space Telescope. And maybe I'll just... all right. Yeah, I think I have disabled the annotation. Yeah, now it will work. Yes. All right. So, yeah, I think you're able to see my screen right now.
Yes, yes.
Okay, perfect. So what I've done is I have disabled the annotation thing so that people will not be able to
yes.
write or write. So yeah, so we are building this telescope, and my particular role in this particular telescope is over here. It is called as DMD, so deformable micromirror device. So it is basically an electronic device with very small, 1 inch by 1 inch. It will have around 2 million pixels, and each of these pixels are basically, pixels which are there in the cameras, where we read the value of a pixel, which is a camera. Whereas in our case, it is a reflective mirror. So we have 2 million pixels on this particular 1 inch by 1 inch device, which can be flipped. You can either flip it in one direction or other direction. By using this, we are doing something very interesting. There is a concept called a spectroscopy, in which light of a particular star is passed through a slit, which is slit is nothing but just a vertical opening of say 100 micron or so. And then when the light passes through that, it is passed through a dispersing element, which is a prism or a grating. Prism is the one which we learned in our 12th standard or 10th standard. So same prism we use, but at a very large scale. And when we pass light through a prism, it gets dispersed, and it can be observed for missing color. So when we see a color of color coming out of prism, it indicates that the light source is having emitting light in all the wavelengths. Whereas if you see some missing wavelengths, it will indicate that the source from where the light is coming is having some gaseous content in its atmosphere, which is absorbing that particular color. So by doing spectroscopy, we can identify whether a star who is emitting some light is having oxygen on its atmosphere or not, whether it is having water content in its atmosphere, whether it is having hydrogen, helium, and so many other elemental contents can be identified or can be derived by just splitting light coming from any star. So that is a conventional spectroscopy, whereas what we are doing here is we are doing something called as multi-object spectroscopy. So suppose we are looking at some kind of dense galaxy where there are thousands of stars, and we want to do spectroscopy, or we want to get the light individually from each of those stars. By using this device, we can artificially create slits only for those stars and pass that light to the spectrograph. That is, I mean, beyond this, I think it will be too technical for this audience, but What we're doing is we are developing a spectrograph which will have multi-object capability, and that will help to reduce the observation time, which is very precious for such a space telescope. So my particular role is here, but of course we are doing a lot of other things. We are doing imaging, we are doing low resolution spectroscopy, high resolution spectroscopy, and multi-object spectroscopy, that too in a UV zone. So I was saying before that recently there was a telescope which was launched called a JWST. So that telescope is meant to be observed in ultraviolet. Sorry, it is meant to be observed in uh, infrared radiations, whereas this telescope is planned to be used in UV zone. Whereas you know that Hubble Space Telescope is already there, that observes in optical. So we are basically covering all the bands in the electromagnetic spectrum, by which we will be able to determine different physical and chemical properties of astronomical sources, as well as their kinematics, basically how they are going around each other. Those details we'll be able to find out. And our ultimate goal is to find life across our galaxy or outside our galaxy. That is the whole aim. So that was a brief about the INSIST. I will now go to TMT, which I'm very deeply involved for last 8 to 10 years. And now I'm project manager for some of its work packages. So TMT is basically a 30-meter telescope, and it's huge. It's huge because the primary mirror of this telescope is of the order of 30-meter in diameter. So this particular telescope is shown here. This is a primary mirror, and we have to align this primary mirror, which is made up of 492 individual mirror segments, which are polished to the accuracy of 10 nanometer. Each of the surface of say 1.4 meter in diameter. Each mirror is 10 nanometer accurate with its profile, and then it is each of the segment is a part of a hyperbola. So because this is a hyperbolic telescope, not a spherical, so which reduces a lot of defects in the telescope by making a hyperbola. But as you can imagine, we are making a large telescope by using small 500 around 492 individual telescopes, and that is very, very challenging. As well as each of them are part of hyperbola, as I said, and they need to be aligned in presence of wind, vibration, earthquake, disturbances, then thermal deformations, and so on and so forth. So it requires something called as active and adaptive optics. And I'm part of this active optics group, which is helping this telescope to be aligned continuously, and not only aligning, but once you build such a precious telescope, which cost roughly $2 to $3 billion once it is completed, it will be completed around 2030 or so. Another 10 years we're going to work on this telescope, and once it is completed, it is going to observe such a precise with such a precision, as well as its life is supposed to be 50 years. So this telescope should work continuously for 50 years duration. So hence the components which we are making, they need not to be only accurate, but also they should be reliable over a lifetime of the telescope. And then these telescopes are kept on top of a very tall mountain, which is in Hawaii, and they will be exposed to extreme atmospheric conditions, and they have to survive. So that is a challenge. So this is how we are making it. We are making a small around 492 segmented telescope. Each of the segment is 1.4 meter. And just to give you perspective, in India, we have the largest telescope is of the order of 3 meter, whereas in the world, the largest telescope which is made so far is of 10-meter diameter. So what we're building is almost 3 times bigger in the diameter, which also increases complexity few hundred times, because the components which we are using are very different than the existing telescopes. And as you can see here, each of the segment is shown here. So this is one module, and such a 492 modules need to be fabricated. There on top, you have a glass. In the middle, you have a very complex mechanical support system, and all our basic mechanical concepts which we learn during our engineering, all our electronic concepts which we learn in our engineering, and so on and so forth. Almost all the branches of engineering are getting utilized to its extreme for building such a complicated telescope. So we have 492 segments, 492 support structures. We have 3 actuators. This is my expertise actually, to build such kind of design and build such kind of actuators. So there are 3 of them, and Indian industries are helping us to manufacture or mass produce such actuators. So we need around 1500 such actuators. In a minute, I'll show you how it looks. And then there are sensors. These are basically glass blocks which are coated with a gold layer, and it is basically a capacitive edge sensor. So it is we just basically making two capacitive plates, but they are accurate to give 1 nanometric displacement measurement. And these actuators, which I said, they are of 1 foot by 1 foot, whereas their accuracy is around 4 nanometer. So we need 14 around 1500 actuators. We need around 3000 sensor pairs like this, and 500 odd meters and support structures for this telescope. And entire this thing is part of India's contribution. So this particular slide shows you how we detect the deviation of a mirror and how we correct it. So every intersegment of these segments of hexagons, there are sensors which will detect the deviation, and with the help of actuators, we will correct it. And as I said, it has to be done very fast. So every second we do correction 200 times, and the correction should be such that at a 30-meter diameter, the overall RMS or overall surface deviation should be within 10 nanometer. So this is how actuator looks like. This is what we built last year, and now presently we are working with some other industries to fabricate this actuator. So this is responsible for 4 nanometer positional accuracy, and this is responsible for 1 nanometer positional accuracy. This is a capacitive edge sensor. As you can see, these are the plates which are formed on top of a glass block with a very thin gold coating on top of it. So if we see this particular telescope, I'm just giving you a case study of large astronomical projects in India, but eventually you will get to know what is the scale and what is the scope in this kind of telescopes. So TMT is a kind of nodal TMT is a large consortium of 5 countries: India, China, Japan, Canada, and USA. And together we are building only one telescope. So you can understand how complicated it will be and how much money it requires to build this kind of telescope. And India's contribution is only 10%, where we give mirrors, we give entire software for this telescope. We build large instruments of the, like you can see a person in comparison with the camera. So this is just a camera of this telescope. So telescope is even larger. We're giving actuators, sensors, entire electronic boards, and support structure will be supplied by India. So, and that consists of 10% only. So remaining complexity is even higher. So I gave you example of a TMT which is shown here, but at present in entire world, there are so many mega science projects going on which involve enormous amount of kind of engineering. It involves enormous amount of scientific expertise, as well as it requires a lot of money, and hence all these projects are happening in collaboration with multiple countries. And what I'm showing here are the projects where India is partner, and you can have a scope of working for one or other telescope in coming time, because these are in a initial stage of development, and next 20 to 30 years we are going to work on these projects. So I'm fortunate to be part of TMT, but you will be having opportunity to work in any of these projects if you are interested. So there is a telescope called as Indian Neutrino Observatory to detect neutrinos. There is a CERN telescope. This is a telescope. This is not telescope. This is a scientific experiment which was responsible for finding God particles or Higgs boson particles some time back, and it is still working. Then we have FAIR. This is basically physics experiment where they are able to find. They are trying to find antineutrinos. And then there is another telescope called a Square Kilometer Array. This is a large radio telescope. Then here is an optical 30-meter telescope. Then there is an ITER experiment. You might have recently heard that in China they formed like this kind of created sun on ground. So that is similar to this. This is an ITER wherein multiple countries have come together to demonstrate that whatever reaction goes on sun, which is nuclear fusion, can be created on Earth. Because if we manage to kind of conduct such an experiment where we are able to have a sustained nuclear fusion reaction, the energy need of entire world can be taken care. So that's why people are trying to just demonstrate. This is just a demonstration experiment, costs around $100 billion or so. But there are several countries which are part in this, and India is also a proud partner in this. And then there is another LIGO project. You might have heard recently that gravitational waves wherein two stars collide with each other, those waves which are created by such a massive collision can be detected, And such project is also going on in India, which is called as LIGO India, and it's not very far from where you are attending this presentation. This is located somewhere near Pune. So this particular telescope is also, it's basically again a physics experiment, but meant for astronomical purposes. So as you can see, with this telescope, we'll be able to explore the universe in different way. But ultimately, what we want to know is how we came here, how humans, how stars and planets have evolved, and how life is evolved, and is there any life elsewhere in the universe? That is the ultimate goal. So yeah, with as I said, with this kind of telescopes, we'll be able to see a lot of things right from our solar system, which is within 1 light year distance, and whereas we can see our planets within our solar system, and with these telescopes, we will be also able to see extrasolar planets, which are basically planets around other stars. This is also a very interesting topic, because with this kind of studies, we will be able to see, is there any life within our vicinity apart from Earth? So that is also exciting. Then we'll be able to see how stars and planets are forming, how Milky Ways and nearby galaxies and their black holes, because almost every galaxy has a black hole at its center, and which was kind of prominently proven, I think 2 years back, and they won Nobel Prize for detecting a black hole at the center of our own galaxy. So such kind of observations and discoveries can be done. We will be able to see how a galaxy evolved. We are staying in one galaxy, but there are so many billions of galaxies across the universe. We're able to see how universe began, and we will be able to, combining multiple observatories and multiple science experiments, we will be able to do something called as multi-messenger astronomy, wherein you are observing same thing with two different instruments. But when we are doing this kind of science experiments, one of the baseline thing which we always remember is, of course, these telescopes and these instruments and these science projects are done to solve some problems, solve some question which is presently unknown or unsolved. Whereas when we build such a massive instruments and such a massive kind of telescopes, what we end up is finding and knowing that we have a universe, or we have a kind of things in this universe which are unknown to us, and that kind of discoveries which we can't even imagine at this point of time. Such kind of discoveries can be made by building such large telescopes and large instruments. So that is something which is very exciting, that we will be able to do serendipitous discoveries as we go along. So that is something very, very exciting. And many of these major breakthroughs which have happened in astronomy are due to such kind of discoveries. Yeah. So with that, I will just quickly take you to career in astronomy. Of course, there are different ways in which career can be done. So previous slides was just to tell you that there is a lot of scope in doing career in astronomy, and hence you can look at it a little more seriously if you're not already looking at. I'll specifically mention about career in astronomy in India, but of course there are other options outside, which I will touch upon very briefly. So in order to do career in astronomy, the best and surest path is to do PhD, because that will give you a lot of freedom and lot of opportunities in after you are completing that, and you will have a you'll be in a position where you can choose what kind of life you want to live in astronomy. So doing a PhD, irrespective of which branch you're coming from, is the ultimate you should be the ultimate goal of any student. Of course, you can do PhD in astronomy after doing BSc, MSc, and then PhD. Whereas I know that most of you are from BTech background, so from after BTech you can do ME, MTech, and then do PhD, and also you can do direct PhDs. Also, there are some universities who offer direct PhDs like IISc Bangalore. So once you're done the PhD, you will get these opportunities. One is like you can be a professor, you can be a scientist, you can be an engineer, and of course, if you're not interested in doing PhD and still want to be associated with astronomy, you can join as a technical support in different engineering backgrounds like civil, mechanical, electrical, electronics. And of course, those who are not belonging to any technical fields, like when I say technical engineering field rather, or science field, even administrative positions are also there for people who are not from science background. So there are a lot of opportunities because these are such a massive infrastructures and massive systems which need to be driven by people from all across the field. So if you are interested in this field, you have different professional opportunities across India. So within India, PhD programs are run by different institutes as listed here. We have ARIS Nainital. They have PhD as well as MTech PhD program. Then there is IISc where they have direct PhD program in astronomy. Then at IIA Bangalore where I'm studying now, or rather I'm working now from last 11 years or so. Here we have direct PhD as well as the MTech PhD program. Then there is a Raman Research Institute here in Bangalore. Then National Center for Radio Astronomy. This is in Pune University. This is a Radio Astronomy Institute. Then Ayuka Pune is also there. They are also into astronomy and astrophysics. Both the institutes are at one place near inside the campus of Pune University. Then in Mumbai, you have Tata Institute of Fundamental Research. And then you have in Ahmedabad, the Physical Research Laboratory. And then apart from this, there are other institutes as well who are into giving astronomy training as well as PhDs. So as I said, since you are from bachelor's background, I will take you directly here. In order to go for MTech PhD in astronomical instrumentation, you need to go through GATE or JEST examination. And then once you qualify to both of these exams or one of these exams, you will be eligible to apply for these astronomy programs, either for MTech PhD or for direct PhD. And based on the interviews, they will select you for the final course. Of course, not only GATE and JEST, there are other exams also which are conducted by different institutes. Like Ayuka is having their own exam called as INAT. IA is having their own entrance exam, and so on and so forth. ARIS is having their own exam. So this is a centralized exam through which all the institutes will be open for you, whereas you can give specific exams as well for different institutes after your bachelor's. And you can appear for GATE exam from your original branch of doing engineering. So for example, if you're from electronics background, you can do GATE from electronics. If you're from mechanical background, you can also appear from GATE mechanical, and so on and so forth. So you need not to do it through physics, but if you're appearing for JEST examination, then you have to appear either from physics or computer science. Those are the only two branches, but everyone from bachelor's degree with any branch are eligible for appearing to these exams. Of course, doing MTech PhD, there is some restriction of some of the branches, like civil engineering branches are not allowed, or some more branches you have to check, chemical engineering, civil engineering. They may not be allowed, but you can see the detailed eligibility of individual institutes which are listed above on their website. So yeah, so going through a competitive exam like GATE, JEST, or similar to this, and then qualifying for interview is a key to do master's or PhD in astronomical instrumentation. And once you are doing the PhD or master's, what you can expect to study, because this is very important. What you will be studying in, what you will be doing in astronomy, knowing that is also very important. So either you will be doing theoretical studies where you're developing new theories, you're doing some simulations like this is one example where two galaxies are colliding with each other and what happens. That kind of stuff you can understand. You can model different phenomena which are in the astronomy. But this is on theoretical side. You can actually take a telescope and observe the night sky and try to interpret it. So that is called as observational astronomy and data analysis. As well as you can do what I do here is basically building telescopes and spectrographs to serve the next generation of astronomers by building a large astronomical equipment. So that is also possible. And then typically since you are from engineering background, I'm sure that you will be interested in something like doing instrumentation in astronomy. Of course, this is for master's program, so I will skip this because this is applicable for people who are from BSc and MSc background. Yeah. But I would also like to say that, of course, not only in India, across the world, there are a lot of astronomy programs. Of course, in India, it is better to do because it is relatively easier and cost effective, because when you're doing PhD in India, you can be assured that you are going to get a fellowship for it. And typically this fellowship ranges from 30 to 35,000. And I think recently it has increased only, with all the things taken care, no fees, and everything will be taken care by the government. So that is one of the best advantage. Whereas, of course, you can earn fellowships for foreign universities as well. So there are two paths. One is via going to the European universities or American universities. So if you're going to American universities, you will have to go through GRE and TOEFL, whereas for European universities, IELTS exam you have to go through. So this is also there. This path is also exists, but it is a bit costlier path. So, but some people will say that, okay, I may not be interested in doing career in astronomy. Maybe I'm already doing job. I'm happy what I'm doing, but I am interested in astronomy. I don't want to do PhD or don't want to kind of get seriously involved into it. But what you can do is you can attend different summer schools and winter schools conducted. Now you're attending this today's program where you're trying to understand what astronomical instrument people do and what is happening nowadays. So similarly, you can attend different programs organized by different institutes across India as well as the world. And due to this pandemic, all the institutes are now open on the public platforms where you can attend their programs freely. You can do internship. Suppose you are in your engineering, you can do internship and try to get flavor of what a research in astronomy means. So there are different institutes who offer internship program for 3 to 6 months. And then also you can apply for doing your projects of your masters, because as I said, though we are studying astronomy, studying stars, galaxies and planets, etc., but we need to do it by using some equipments and instruments which require expertise across the branches. So you can do your bachelor's and a master's project at these institutes. uh, of course, you can attend in outreach programs where astronomy is explained in simple words to different people. So you can interact with the PhD scholars and scientists and try to get feel of what does it mean by doing career in astronomy, and then decide whether you want to go seriously in that direction or not. Of course, you can do online courses and take nice pictures. Nowadays, or even mobile phones can take very good pictures of astronomical objects like comets and planets and yeah, so on and so forth. Of course, Milky Way galaxy is also visible if you take a long exposure by using simple mobile phone. And yeah, of course, you can enjoy the books and different happenings in astronomy. Maybe just I can remind you that in coming time there is going to be a very good event in space program, which is launch of Starship mission, wherein SpaceX is going to launch a very huge rocket. It is one of the largest rocket ever built by humans, and it will be launched in coming week or so. And that is going to be exciting because that is the mission which is responsible to take humans to the moon once again in 2025 or so. So we should be looking forward for such events as well. Yeah, of course, apart from that, if you want to do even more casually, you can just visit different planetariums and science centers across your cities. Nearest to you, there is a science center in Pune as well as in Mumbai. So you can visit that. This is more biased towards the Bangalore-based planetariums and all. So, and yeah, as I said, you can participate in a casual way of doing astronomy, because the reason for that is astronomy is very, very fascinating. You can, anyone who is uh, deeply involved and very casually involved into astronomy uh, aspects can enjoy the kind of um, essence of it, basically, because it is really, really fascinating. It kind of uh, opens up your mind for thinking globally. And then when you realize that we are very kind of insignificant in comparison with such a large universe, then we realize that yes, there is no need of worrying about any problems in our life. There is no need of worrying about who is saying what, how our politicians are working, how we are damaging our ecosystem. All those things will become negligible in front of astronomy, and that is the only way where people can realize their actual position in this universe and how they should be kind of living on this planet happily and sustainably. So that is a kind of feeling which you can get only when you are thinking about astronomy, because astronomy puts you in perspective in comparison with such a large universe. So yeah, so you can anybody can enjoy the astronomy. That's the beauty about this particular subject. So I think that's 45 minutes, I guess. So That's all which I wanted to just introduce to you. And if you have any queries, concerns, questions, please ask me now. As well as these are my contact details. If you want to further write to me, as well as yeah, I'm putting the link of my detailed video of my story. If you are interested, you can always watch it. Yeah. So with that, I would like to thank you. And yeah.
Yes, thank you so much, Prasanna sir. It was a very nice session. Even I got to I went on to become so much interesting about the astronomy after so many long days. So it was really
Yes,
a
it
nice
is.
session. So students, I kindly request you, if you have any questions, you can drop it in the chat box, and I'll be there to help you out, asking your questions to Prasanna sir. So there are two questions which have been earlier posted in the chat box. So one is, can we do the PhD program along with our job or along with any other things which we are doing? So is it possible? And if yes, how?
Yeah, so typically people do, those who are in education profession, for example, those who are professor or assistant professor at colleges and universities, they usually try to do such a means remote programs wherein they conduct their research in their university or conduct the research at different lab, but they work at different places. So such things exist. What you need to do for a PhD is to find a guide, basically, because there is no as such a very hard and fast restriction. What you need is eligibility to do a PhD is basically you need to have a master's degree, or if you are going through bachelor's, that particular university should have that approval, basically, wherein, for example, IASC has a program where you can directly do PhD. So wherever you are registering, they should have a PhD program. So suppose you want to do a PhD in Pune University or Bangalore University or Shivaji University. So they should have a provision of allowing people to register. That is one. Second is you need a guide who will guide you through the process of PhD. So sometimes people will have their own program and you want someone to support uh, that particular project. So in that case, you can find someone who is relevant to that field who can help you when you get stuck in your research. So yeah, finding a right university and finding a right guide is sufficient to do PhD, irrespective of what you're doing. Of course, doing full time helps because that is what gives you a real flavor of doing PhD. And it can be completed in, say, 3 years to 6 years time. You can complete a typical PhD. But if you're working, you're putting energy into the different baskets. So hence, it may take a little more time to complete. But yes, while working, you can do PhD. And there, I have seen many people who are doing job and doing PhD, or who are doing uh, kind of academic job rather, and doing PhD because it helps them in their academic work. Yeah. It is up to you if you wish to do a PhD. Yeah. But if you do it full time, you will get paid also. So that is also another thing, that it is as good as you're getting a salary, because of course whatever numbers I shown there are your stipend, but you also get free accommodation, you will get all the expenses covered, you will get to stay, travel across country. Now you whatever photo you are seeing, this was during my PhD when I went to Hawaii to do some experiment in the telescope just below that sun here in the screen. So this is a Subaru telescope, Japanese telescope, where we conducted one nice experiment on vibration effect on telescope. And these are the world's biggest telescope as of now. These are Keck telescope. These are the ones which are responsible for doing a lot of discoveries, including the recent black hole image. And our telescope, the 30-meter telescope, is just going to come next to this. So there is a small dip over here on this mountain where we are going to put our telescope. So yeah, you get to travel across the world, uh, which is funded by the government. Yeah.
Okay. Thank you, sir. The next question is, it is asked by Pavan, what is the prime difference between the astronomy and astrophysics?
Yeah, actually, to be honest, that difference is very blur. It is, yeah, it is basically not so vividly defined. Whereas when we say astrophysics, we always say about understanding the physics of the subject, which will also have a lot of uh, theoretical theoretical background, or the way I shown you here. So if you had to roughly divide what you're doing in this particular thing, theory, simulation, modeling, we call it as astrophysics, whereas when you're doing observation, it is called as observational astronomy. Of course, it is astronomy, but observational astronomy. When you're doing theoretical studies, it is part of astrophysics, but it is called as theoretical astrophysics. And then when you're building the instruments, it is called astronomical instruments. So to be honest, that definition is very blur. It can be used vividly as applicable. Yeah. So it is not a well-defined thing.
Okay. The next question is from Aditi. What are the opportunities for mechanical students in the astronomy? Because mostly students from electronics have huge lot of scope there. So what about the students from mechanical?
Yeah. So if you see at this particular image, as you can see, there are around 50 mechanical components which are forming this particular actuator. Even these blocks need to be machined using the mechanical engineering concepts. If you see this telescope, yeah, this particular part, which is segment support assembly, it is having 500 subparts. All are very precision mechanical components and need to be fabricated by kind of top companies in the India. So for example, presently L&T is helping us to fabricate these components. So building such a large telescopes does require mechanical components, and I am working with a team. To be honest, I am electronics engineer in my BTech B, and then I have studied astronomical instrumentation. But 50% you can call me as a mechanical engineer, because as I was working on these projects, I have learned almost everything about mechanical engineering, because it is required when you're building such an instrument. You have to build with some components which required manufacturing, material related aspects, and so many other things also. Even this telescope requires a lot of studies in terms of its thermal stability, in terms of its mechanical stability during the vibration events, or during the earthquake events, and so on and so forth. So in my team, we are having some 25 people, out of which almost 20 people are mechanical engineers and 2 or 3 are electronics engineers, of course. Yeah. So it does require mechanical engineers. And good thing about all the astronomy institutes in India, basically they allow mechanical engineers to directly take admission for PhD programs, as well as now astronomical instrumentation program, which I completed in 2017 or so. That time only one institute was offering MTech PhD program for mechanical engineers. Now there are 2 institutes who are offering the same. So this particular branch is completely open for mechanical engineers too. Yeah. Previously it was not, because people were trying to understand what all things we need in this field, and they were allowing particular branches for astronomical instrumentation. But now it is open for mechanical engineers as well. Yes.
Next question, which is also again similar to that, is there any role from environmental engineering students?
Oh, yeah, definitely. So, I mean, I will need further details on when they say environmental engineering. But what I will just explain you, one simple thing which I did during my PhD as well is, look, we are building this telescope which will be kept on top of this mountain, which is in Hawaii, as I shown you here. This is a mountain. On top of this we are going to put this telescope. So correct me if I'm wrong, if I'm assuming that when I'm saying environmental engineering, I'm considering of wind, thermal effects, and then earthquakes, and so on. So vibration related things, effect of wind and vibration, or so that is what I'm understanding. Whereas yeah, so when we are putting this telescope on such a top of mountain, they will be experiencing extreme heat, they will be experiencing extreme wind and extreme cold as well. So we have to ensure that these components which are made for this telescope do survive in such a harsh condition, and our systems work. So during my PhD, I built a system which is called as wind emulator, which is capable of conducting wind experiments over the actuators. You see here this kind of actuators. So I was able to mimic wind disturbances on this actuator in the lab, instead of taking these components to top of the mountain, because that would have been expensive affair. Whereas we were able to use wind wind disturbances on top of this actuator. Now you may say, how you know that what is the wind disturbance on top of mountains? So what we do is we put weather stations on top of these mountains and collect data for almost 10 years before installing a telescope. So we have an understanding of how wind behaves on top of this telescope. What kind of cloud cover is there on top of these mountains? What kind of soil characteristics are there at this particular location? Uh, Going further, again, I can interpret that particular question in so many other ways. We also ensure that these telescopes, wherever we are putting, they are not harming the vicinity of this particular mountain. So, for example, whenever we put these telescopes, we ensure that they are there for limited time. And once the telescope is decommissioned, we restore the mountain as it is. We don't harm the local environment by disposing our waste over there. So everything which gets disposed comes down to the mountain, and it gets recycled. Nothing is thrown out on these precious mountains. Yes. So again, I will be happy to answer further clarification on these questions if they can write to me on my email. Yeah.
Sure. So students, I hope you all have noted down the email ID so that you can get the further help. The one more very important question from one of the student, I guess it is again Pawan. So how can we get enrolled to the internship programs which are by ISRO or DRDO or by Tata Institute of Fundamental Research, or even after internship program, there are also some opportunities into these institutions as well. So
correct.
how to
yes.
get into those all the opportunities?
Yeah. So suppose you are in your master's or bachelor's program and you want to do some internship in your free time during your after your exam breaks. There are a couple of ways. All these institutes have a pre-planned programs. These are called as summer internship or winter internship programs. Our institute is having, and many other institutes across India are having these programs. So, and on their website, you will get details about how to apply and other things. But bachelor's and master students are typically eligible for doing internship, and these are pre-planned ones, whereas you can also do internship. So many students work with me apart from the conventional internship programs where they get paid as well, by the way. So if you're doing a direct internship, I think there is no paid internship, but you can conduct your projects and bachelor's and master's project at such institutes by doing internship for a couple of months. Sometimes they come here, sometimes they do it remotely if it is possible. And the best way to find it is basically go to a website of all the premier research institutes which I mentioned, and there will be a tab called as internship program. Whereas you can also go to the tab called as people, where you can find who all scientists are there who are working in different fields, and you will find their profiles. And if you know that, okay, you are interested in, say, cosmology, then you can find people who are working in cosmology and write an email to them saying that, look, I am having this free time in after my exam in 2 months time, and I would like to work on some interesting project with you. And they will definitely respond, because we do entertain such a request, because we know that if you get flavor in astronomy at this particular age, if you are really interested, you will get hooked to that subject and you will make efforts to come into this field. Because see, presently in India there are roughly 200 to 300 professional astronomers, whereas in coming 10 years we are going to require at least 1000 to 1500 professional astronomers. So in the last 20 to 30 years of history of our astronomy in India, which is a professional history, you can say, of course, people are working from 1,000 years back. But if you see seriously, we are building telescopes in last 20 to 30 years. We are building space missions and all. But there are hardly 200 to 300 scientists who are fully devoted to studying these astronomical phenomena. Whereas now, as I indicated you, billions of dollars are invested into fabrication and installation of these telescopes and these science experiments. And we are in need of serious researchers over next 10 years. And that number is of the order of 1000 to 1500. So in that context, you can see there is a huge scope, but there is a need of serious astronomers who are really interested in this subject. So there is definitely a scope. Yeah.
Yeah, one more question, which is again associated with that. Is there any eligibility criteria to apply for these internships?
Yeah, I mean, typically we don't discriminate any branch as such. Anyone who is interested and they have some, sometime what we do is, suppose a student from architectural engineering or architectural branch is interested into doing internships. So we give them associated internships. Like, for example, they will be interested in understanding how a typical observatory works, and they will model that observatory in their kind of field. Whereas if a mechanical engineer is there, we will give them problem associated with designing some mechanical fixtures or jigs, which are used in our projects, bigger projects. So if electronics person is there, we will give them assignment of developing some new electronic circuitry, which will be useful further in our projects. So based on who is applying, we do entertain and give them similar projects in not only at our place, but across India. Whereas when it comes to doing serious studies, it requires a background because you're starting from master's or PhD. So of course, it requires some basic background from your bachelor's degrees, and there it comes somewhat kind of scrutiny, wherein some branches are eligible for doing research or doing these courses, and some branches are not. But of course, I have so many examples wherein a person who did civil engineering, who was not eligible for direct masters or PhD. What he did is, after his BTech, he did MSc, which is allowed, MSc Physics, and then he applied for PhD program. And recently, he got degree as well, PhD degree. So people who are desperately interested, they can figure out how to do PhD in astronomy. And again, I'm saying, if you are interested in doing career in astronomy, PhD is the only way, because that gives you a respectable position where you can choose what you want to do in rest of your life.
Yes, absolutely. Now the another question is a bit out of context, but it is a very contextual in the favor of all the engineering student, because usually whenever they enter into a final year, they are very much preparing for the GATE exam as well. So
Yes.
there are some students who have asked the question how to prepare well for the GATE exam.
Yeah, actually, one thing is, I mean, during my, this is my experience. Of course, it may vary, because, and I would like to warn you that this is not the only way to do preparation for GATE, because I have seen many people who have done it differently and got even better marks. But the way I approached this particular thing is, I wanted to understand what is this exam. So I appeared it multiple times. While I was in engineering, I started appearing it in my second standard, second year of engineering itself, because that time it was allowed to participate, or at that time it was allowed to appear for this exam as many times you want. So I appeared, I think, 2 times before completing my bachelor's, and I got to know what kind of exam is this, what need to be prepared. And then I spent around 6 to 8 months preparing for this exam. But you have to prepare hard, because if you are appearing, you have to be seriously preparing, because uh, now I can imagine for electronics engineering branch, there will be at least 2 lakh to 3 lakh students who will be appearing every year. And you want to be within top 1% or top 2% of that big crowd. So for that, you should be also among the top 1% or 2% who are preparing seriously about such exams. So preparing very hard is very important. Understanding what is this exam and what kind of questions you can expect, because it changes as time passes. So that is also important to understand what are the typical nature of these papers, these exams. And then you should be good at few subjects. So if you have 8 subjects, you should be at least good at 4 to 5 subjects, because as you know that for GATE exams, you don't have to get 100 out of 90 to be on top, right? So if you even if you get 60, 70, you will be having a very respectable score. And gate and jest and other similar exams are just a qualifying exam that you have to remember. You just need qualifying marks. After that, there will be an interview which will decide your fate. So you should be good at gate, but also you should be good at what you have studied in your engineering, and you should be able to answer the questions. So prepare for the interviews, prepare for few subjects which you like, because preparing everything is impossible. Nobody can prepare all the 48 subjects which are taught in our engineering. But if you prepare half of them, you will be good. Yeah. So, and then of course, give as many mock examinations as possible. So during our time, I remember we were around 20 odd kind of friends who were preparing for this exam. And for 8 continuous months, we were preparing. And last 3 months or so, we were continuously giving mock exams, basically almost 90 to 100 papers we solved, which are kind of model papers. And then you get used to kind of that kind of questions by solving them repeatedly. And also you will have courage of appearing for such exam, because it takes a lot of courage to focus for 3 hours and attempt every question right, because there is no scope of giving wrong answers there.
Yes, absolutely.
So it requires preparation, but if you are an average student who is deeply interested into doing something and going for masters through these exams, of course you can do masters without these exams as well. But if you want to do it at IITs or NITs or such a research institutes, if you prepare very hard, it's very much possible. I am example. Many of my friends are examples.
Yes, of course. So, dear students, I guess you have a lot of other questions as well into your mind to ask, but as we have a limited time, I am very much thankful to Mr. Prasanna sir for sharing his insightful thoughts and his valuable experience into the space and the entire astronomy, astrophysics, because in the era of the software boom, this is really essential for all the students to also know what and all the opportunities they can have into these kind of sector as well. So the entire address was very much insightful, very much productive and informative as well. So I must express my sincere gratitude towards Dr. Prasanna Deshmukh for being available over here for the entire duration of 1 hour and sharing his valuable insights in front of all of our students. And also, I'm very much thankful to all the students who have joined and they have asked a bit of questions, which has made this entire session very interactive. So thank you all. Thanks a lot. Thank you, Prasanna.
Yeah, thanks Chetan, and thanks Sandeep and Prasanna for conducting this program. And I would like to be part of your journey in coming time as well. And as I said, I'll be always open for any discussions and queries which anyone who has attended today's program who is interested in this subject. I'll be always open for any discussion. Thanks a lot.
Yes, thank you, sir. Thanks a lot. Students, it is a great opportunity for all of you to connect with such an eminent personality from the space, from the astronomy, because we rarely find such a people around us. So you can connect him if you have a very keen interest into the astronomy, space, and astrophysics. So thank you so much. Thanks a lot. Bye-bye.